All right, so good morning. We are solving triangles using the law of sines. So I'm recording right now. They can't hear you. Don't worry about it. Okay, they'll just hear my voice. But we have this beast right here. This is what I call the decision tree for solving triangles. And when we're solving triangles, these are oblique triangles, meaning they don't necessarily have a 90-degree angle in them. And you should have learned over the weekend how to use the law of sines. I believe that the law of sines was introduced to you in geometry class. Was it? Was it not? I'm getting a definite no. Okay, all right. And I'm getting a yes over here. So, okay, so we'll make this as clear as we can. I cannot encourage you more to answer or ask questions during this time. Okay, so your triangle congruence theorems said this: if you were ever given 3 angles in a triangle, you could not prove congruence, but you could show similarity. So meaning that if you have a triangle that measures 60, 60, 60, and another triangle that measures 60, 60, 60, those are not the same, are they? However, their sides are proportional, meaning if this had a side of 3 and this had a side of 6, then this would have a side of 3 and this would have a side of 6, okay? It would be twice as big in that situation, okay? But they're not congruent. So angle, angle, angle does not show congruency. But you did learn that angle, angle, side shows congruency, and you learned that angle, side, angle shows congruency. And so the lesson that you were supposed to go over, you would use the law of sines to solve these triangles. Today, we are going to look at, well, side, angle, side, and side, side, side also show congruency, but that's for a different time. We need to talk about the law of cosines later on. But today, we finish off our law of sines by talking about SSA, and that causes a problem. Side, side, angle was not enough to show congruency, because backwards it spells donkey, right? And that's a big problem. You learned that that was the naughty 3-letter word, and it caused all sorts of issues. Today, you should have a couple light bulbs go off in your brain saying, oh, I get now why that didn't work in geometry. And some of you who maybe have been suppressing geometry, you should feel okay to allow that to come back and be like, okay, it's making more sense now. That's generally what happens during this time. The last thing that we need to make sure that we are in the clear understanding of is this. I want you to know that as I bring this up, many people are confused about this. Many people are confused about this. It's okay to be confused because it's probably about 30, 40, 50% of people. Just make sure you ask the question. If I give this angle as 60 degrees and this angle is 35 degrees, and this side as 10, and then I'm going to do this as 60 degrees, this as 35 degrees, and this side is 10. One of these triangles is angle, angle, side, and one of these triangles is angle, side, angle. Which one of these triangles is angle, side, angle? Is it the first one, or is it the second one? I'm getting the first one, and I'm seeing a lot of confidence. It is the first one, but let's talk about why. Some people say it's this one because you start here, you go angle, side, angle. Well, if I start here and go this way, I also get angle, side, angle, don't I? That's the confusion that people have. They say, well, if you start at an angle and you rotate this way, you go angle, side, angle. Whereas if you go this way, you go angle, angle, side. That is the wrong way to think about it. The correct way to think about it is that you have 2 angles and the side is located in between the 2 angles. That's why it's angle, side, angle. It sits between the 2 angles. So if the 10 was over here, it would be between the 2 angles. That's what that means. We are now ready to begin the lesson. Let's see what happens when you have a triangle where the opposite leg is shorter and you end up with 2 solutions. Side, side, angle. Here we have it. Does everybody agree in this situation that this is side-side angle? Notice how the side opposite is longer or shorter than the other given side. Which one is it? Shorter than the other given side. Our decision tree, as we would look at it, tells us that when the side opposite the angle is shorter than the other given side, you either have no solution or you would have two solutions. That's what happens. So let's see what this produces. As you have this set up, you would say the sine of 30 divided by 8 is equal to the sine of, we'll call this theta, sine of theta divided by 10. And as we set that up and solve it, the sine of 30 divided by 8, take out my handy dandy calculator. And I get 0.0625 is equal to sine of theta over 10. When I multiply both sides by 10, I get 0.625 is equal to the sine of theta. Notice how sine is less than 1. In fact, the largest value that sine can be is 1. And what's the least value that sine can be? Think about the graph of sine. It goes up to 1, it goes down to -1. Sine must stay between 1 and -1. Everybody agreed? So can sine have a value of 0.625? Yes, it can. Here is the problem. In what quadrants is sine positive? All students take calculus. 1 and 2, right? So sine is positive here and sine is positive there. That means that sine has a value of 0.625 both in the first quadrant and sine has a value of 0.625 in the second quadrant. What kind of angles are in the first quadrant? Acute angles or obtuse angles? Acute. So theta could be acute or theta could be obtuse. Look at this right here. Does theta look like it's acute or obtuse? Acute. Would you agree that that is also a triangle? That is a 30-degree angle, one side of 10 and one side of 8? It is. Is theta acute or obtuse? Obtuse. See how you have two different constructions that produce a 30, 10, 8 triangle? You don't know which one it is, and you therefore have two solutions. One with theta being acute, and one with theta being obtuse. This is the most complicated part of the lesson. Once we get through this, you're going to be fine the rest of the way. And trust me, we're going to come back to it. Watch what happens if I do sine inverse of 0.625. I get 38.68 degrees. Is that the acute angle or the obtuse angle? Acute. If I simply subtract that from 180, 180 minus that answer, I would get 141. 141 would be the obtuse angle. Watch what happens if I take the sine of 141.31. I get 0.625. You see the sine of 38.68 is 0.625, and the sine of 141.31 is also 0.625. Good. Let's try a different example. Suppose we have the same situation. We have a 30-degree angle, and we have a side of 10, and then we're going to draw another one. We have a side of 2. you think you could make a triangle with those dimensions? Why? What seems to be wrong about it? What seems to be wrong about the last side? Yeah, it's too short, right? Like sometimes you have a dimension, it just doesn't work out. Like you're trying to, it's like, come on, get to the bottom there. It just doesn't, it's like two. Just won't go. What's wrong? Well, that means it's an impossible triangle. How would we know? Well, we'll know very easily. We set it up. We say the sine of 30 divided by 2 is equal to the sine of theta over 10. The sine of 30 divided by 2 is 0.25, is equal to the sine of theta over 10. When you multiply both sides by 10, we get 2.5 is equal to the sine of theta. Can sine be equal to 2.5? Never. You said that the maximum was 1 and the least was -1. That doesn't work. Check it on your calculator. We go second. Sine inverse of 2.5. What do we get? Domain error. It's angry with you. It can't happen. So you see how the mathematics, it will tell you what kind of piece it is. I'm trying to help you understand the geometry of it and why it looks the way it does. Now let's check out the other one, okay? Side-side angle, the opposite leg is longer than the other, okay? So we're going to do similar situation here. We're going to go, this is 30 degrees, and we're going to go, let's back off that. There we go. There we go. So we'll go 30 degrees, we'll go 10, except now the side opposite the angle is going to be longer than the other given side. We're going to call this a 12. Now, you actually covered examples like this the other day. Now, we said that there's just one solution. Well, why aren't there two in this situation? Well, because just watch what happens. Like if I grab that side and I do the whole like pendulum thing and swing it over here, it doesn't connect with the other side, does it? It doesn't. So that's why if the side opposite is longer than the other given side, that's why you just have the one solution. So our goal today is to be able to diagnose those three situations and be able to work it out. So we try 3 problems. Side A is 22, side B is 12, and angle A is 42. We label A, B, C, A, B, C. I know angle A is 42 degrees. Side A is 22. Side B is 12. 42 degrees, 22, and we're going to do 12. We all good? Okay, what kind of triangle do I have? Angle, angle, side, side, angle, side, 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 angle. What is it? Two sides, one angle. Is the angle included between the two sides? No, so it's side, side, angle. So we got the donkey situation going on. So let's check it out and see what it says. It says, if you end up with side, side, angle, determine, is the side opposite the angle shorter than the other given side, or is the side opposite the angle longer? Which situation do I have? Longer. It says there's just one solution. So that's what I do. I do one solution. Set up the law of sines and solve. Sine of what over what? 42 over 22 is equal to sine of what angle are we now finding? B. Sine of angle B over side B, which is 12. To solve this, I'm going to multiply both sides by what? 12. So 12 sine of 42 divided by 22. Boom. Can sine be equal to 0.3649? Like, is that an option? Can sine take on that value? Yes. We inverse the answer. You guys know how I pull up ANS? I go second, negative sign, and it just takes whatever you press there and puts it in there. It's a nice time saver come this kind of lesson. Okay, so use that. And I get 21.41. So angle B is 21.41 degrees. You tell me, what's the next easiest part of the triangle to find? The third angle, because they all add up to what? 180. So 180 minus 42 minus 21.41. I get 116.59. I'm going to try to make sure we finish right by 43. If we have to stay late, we got to stay late, folks. We got to finish this off. Side C. Can I use the Pythagorean theorem? Why can't I use the Pythagorean theorem? It's not a right triangle. So how do you find side C? Law of sines. It's a beautiful thing. Sine of 42 over 22 is equal to sine of 116.59, and you divide it by side C. So I will multiply these two, and I'm going to divide by the sine of 42. So sine of 116.59 times 22, and I have to divide that by the sine of 42, and I get 29.40. What's your biggest angle? Angle C, 116. What's your biggest side? That's good news, right? Check and make sure they're verified appropriately. Got it? All right. We all good for that first one? That should be a review of what you did this weekend, right? Okay, let's get to the more challenging stuff. This one says we got side A, side B, and then angle A. So I'm going to draw this guy out. A, B, and C. My dear friend Morgan Anfinson said, do our triangles have to be drawn proportionally to like how they're described? And I say, no. Just draw them, folks. Just draw them. What kind of triangle? Side-side angle again, right? Stupid donkey. I feel like we should watch Shrek in honor of it. Great movie. All right. So side-side angle, donkey says I got to go down here and decide, is the side opposite the angle longer than the other given side or shorter than the other given side? It is shorter. And shorter means I either have no solution or I have two. There's no chance that I've got just one solution. No chance. Y'all agreed? Okay, so let's see which one we have. Here's how we figure it out. We don't know until we actually set up the law of sines. Let's set it up. Sine of 85 over 15 is equal to sine of B divided by 25. So as I want to solve for that, I got to multiply both sides by what? 25. So I'm going to go 25 sine of 85 divided by a 15er, and I get that, 1.66. Can sine take on a value 1.66? No. If you were to inverse sine of that guy, you get a domain error. You know because of that there is no solution. So sometimes on tests, people are confused. They're like, well, I don't know if it's no solution or not. They just like write no solution. I have to see that you've come up with a sign value that's inappropriate. That's the work that you need to show to get the credit for the no solution piece. Get that? Good. And the last one. What situation do you think we're going to come up with here? Got an A, B, and C, 12, 31, and 20.5. think we're gonna make it. Everybody agree? I still got a side-side angle thing going on. So I look at my decision tree, and it says side opposite angle longer than the other given side or shorter than the other given side. Which situation do I have? Shorter. You don't know whether it's a no solution or a two solution. But it says when solving for the missing angle, if sine is less than 1, then there's two solutions. When solving for the missing angle, if sine is greater than 1, there's no solution. So let's set it up and see if we come up with a result that's greater than 1 or less than 1. I set it up. Sine of 20.5 divided by 12 is equal to sine of b over 31. Multiply both sides by 31. Sine of 20.5 divided by a dozen is equal to 0.9047 is equal to the sine of b. Is it possible for sine to have that value? Now is when you set up the two triangles. Remember, there was either no solution or there were two. So that means that there has to be two. It's no just one option, folks. So we set up the two solutions. In both situations, you know that angle A is 20.5. In both situations, you know that side A is 12. And in both situations, you know that side B is 31. Those stay the same for triangle 1 and for triangle 2. Here's what's different. When we solve for this angle right here, one of the triangles is going to have an acute angle. The other one's going to have an obtuse angle. If you remember, I showed you that at the beginning. So we sine inverse the answer, and I get 64.78. Angle B was 64.78 degrees. Usually what everybody does during this time is they start like solving the rest of the triangle. No, don't do that yet. Find this angle first. This is the acute. What do you think I do to find the obtuse angle? Subtract it from 180. So 180 minus the answer, and I get 115.22. That's what ties those two together. I can now solve for the rest independently. They don't rely on each other anymore. This is the thing that links the two together. Okay? That's what links the two together. That's it. Find side or angle C, right? Subtract from 180, and then use the law of sines. This group right here, I think we got to where we need to be. The key, hold on. So the key is just subtract from 180, use the law of sines, subtract from 180, use the law of sines, agreed? Folks, this whole decision tree thing, I made this after teaching this for years. And after I made this and people started following along with it, they started to really understand this better. Use it, learn to understand it. If you don't like it, make one of your own. Show it to me, I'd love to see it, okay? Hey, great to see you. I'll see you again on Wednesday. And we will have time in class on Wednesday to ask questions.